Good afternoon, class. We will now finish chapter 10, and just as we saw in chapter 8, we talked about our population mean when sigma is known and sigma is unknown, and then we discussed our population proportion, P. We are going to do the same for chapter 10. So we are going to finish chapter 10 by looking at hypothesis testing for population proportions. We have seen in the previous two sections how to apply the principles of hypothesis testing to questions regarding population means, mu. In this section, we will turn our attention to questions about population proportions. And remember that a population proportion is denoted by the letter P. The test statistic we will use is a z-value, and this is our last formula in our left-hand column on our Exam 5 formula sheet, our z formula. And notice it is the only formula where we have a p-value. So recall that the notation p, remember this is read p hat, it looks like a little party hat. P hat is used to represent the sample proportion. Recall from sections 10.2 and 10.3 that there are three types of hypothesis tests: a left-tailed test, right-tailed test, and a two-tailed test. These three types are determined from the symbol used in our alternative hypothesis, HA, and create the following three decision rules for our rejection region. Right? Remember that a left-tailed test, we have a leftmost boundary that blocks off an area of alpha. This is our rejection region. Our right-tailed test, we have a rightmost boundary value, and it blocks off an area of alpha, and this represents our rejection region. Our two-tailed tests have both a right boundary and a left boundary, and each of these values block off half of the area alpha, alpha over 2. And if we land in either of those regions, we're going to reject the null hypothesis. For a hypothesis test for a population proportion, we will reject the null hypothesis H0 if z is less than or equal to negative z alpha for a left-tailed test, z is greater than or equal to z alpha for a right-tailed test, and the absolute value of z is greater than or equal to z alpha over 2 for a two-tailed test. This is how we mathematically write the statement that our test statistic falls within the rejection region. And this is exactly what we saw in section 10.2. Let's look at an example. Researchers in an Apple-funded study reported that 0.5% of participants received irregular pulse notifications indicative of possible AFib, or atrial fibrillation, from their Apple Watches. To improve the benefits of pulse notifications, it is important to identify the percentage of people receiving false notifications. Suppose that a cardiologist is concerned that the reported percentage of people receiving these notifications is not accurate. To perform the hypothesis test, the doctor conducts a simple random sample of 2,315 people in the area who own Apple Watches and asks if they have received a notification of an irregular heartbeat. 9 of the respondents claim to have received such a notification. Does this evidence support the cardiologist's claim that the percentage of people who receive notifications of irregular heartbeats is not 0.5%? Use a 0.01 level of significance. We begin by stating the hypotheses. Now, recall that the cardiologist's claim is that the proportion is not 0.5%. Now remember, whenever we write percentages in our mathematical statements, we convert them to decimal numbers. So moving the decimal over, we get p not equals 0.005. And for our null hypothesis, we just simply replace the symbol to an equality. Now to compute the value of the test statistic, we need to pull out and label all numeric values given in the problem. Now notice that our sample size was 2,315 participants. Now in this case, they don't give us our p hat, but we need our p hat. But they do give us the statement that 9 of the respondents claimed that they did receive an irregular notification from their Apple Watch. Now remember that p hat is the number that satisfy our characteristic divided by our total number given in the sample. Now our characteristic in this case is what we are interested in. And we are interested in people who have received an irregular notification from their Apple Watch. So we get 9 over 2315, which is approximately 0.003888. Now, again, personally, I don't mind working with fractions because my calculator will work with them just fine. But I know a lot of students prefer working with decimals. When you're working with decimals in calculations, do not round your decimal. Use 6 decimal places. It will affect your solution, and it will be wrong. Use 6 decimal places whenever changing a value to a decimal number. So let's make these notes. We will assume all criteria is met to use the z distribution. Remember from chapters 7 and chapters 8, there's restrictions on when we are allowed to use the z distribution when talking about the population proportion. Our problems are going to satisfy that criteria. And 2, we use the value p equals 0.005 from our hypothesis. Remember in our formula, we need a p hat, an n, and a p. And so we'll use our value p from our h naught. Plugging these values in, we get z is approximately negative 0.76. And again, we're back to z values, so we always round to 2 decimal places. Now to create our decision rule, this is our step 3 for our rejection region, we first notice that alpha given in the problem is 0.01. Since the symbol not equals appears in HA, we know this is a two-tailed test. So we may use table B directly and see that z equals 2.575. Now remember that two-tailed test, we use table B directly. A one-tailed test, let's just remind ourselves, the one-tailed test, a right tail or a left tail, we have to do the trick. And what is that trick? We don't look up alpha, but we look up, that's right, we said it, 2 times alpha. So in this problem, our decision rule is given by the absolute value of z is greater than or equal to 2.575. Now, since our test statistic, this was our step 2, was calculated to be negative 0.76, negative 0.76 becoming positive becomes 0.76. This does not satisfy our criteria. It's not bigger than 2.575. So we conclude that we failed to reject our null hypothesis H naught. And again, here's a visual if you're interested. And our interpretation, failing to reject the null hypothesis means that at the 0.01 level of significance, the evidence does not sufficiently support the cardiologist's claim that the proportion of Apple Watch users who get a notification of an irregular heartbeat is different from 0.5%. Now, I've only done one example problem for section 10.4. There's many more found in our ebook and, of course, in our practice problems in our homework. If you need more help on these problems, again, please post in our Module 10 discussion board, or please send me an email to my jprince-lubawy@una.edu email. I can work through some homework problems with you, or I can give you some additional problems to work through and have you practice so that you're on board and feel confident solving these types of problems.